So this video is all about what we call compound figures, and specifically solving for angles in compound figures. And when we talk about compound figures, what we really mean are two-dimensional figures or shapes that have extra parts, and we'll take a look at a few examples of those. But the first thing we need to do is make sure that we remember all of those special types of angles and angle pairs. We have two special names for angles. We have names for lots of angles, but special types of angles in particular that we need to worry about when it comes to compound figures are right angles, which have a measure of 90 degrees, and straight angles, which have a measure of 180 degrees. Anytime you see a straight line that's intersected by another line, you can assume that the straight line is 180 degrees unless you're told otherwise. And one of the important things is that we can't necessarily assume that an angle is a right angle unless we see that box there in a corner. If we have a straight angle that is cut by something else like this, these two angles together make up 180 degrees, so we call them supplementary. That just means that the measure of angle 1, that's what the M stands for, plus the measure of angle 2 is equal to that complete 180 degree angle. If we have an array or a line segment that intersects a right angle, we call them complementary angles instead, but the idea is still the same. These two angles add up to 90 degrees in total if we know that this angle here is a right angle. So supplementary and complementary angles, two special types of angle pairs. The last special type of angles that we need to talk about before we get to compound figures and we need to remember are vertical angles, which happens when two line segments, rays, intersect like they are here. So in this case, the vertical angles are 1 and 3. Because they're the ones that are diagonally across the intersection. 4 and 2 are also vertical angles here, and we can see that because they're made from lines, the line that's being drawn in purple right now, angle 1 and angle 2 actually create that line along with the blue dashed one that I'm highlighting here. So 1 and 2 are supplementary angles. They create that straight line in purple. 2 and 3 are supplementary angles. And so really it's the angles that don't share any of those rays from the intersection. Those are the vertical angles. 1 and 3 and 2 and 4. And the important part about vertical angles is that their measures are always the same. And things like vertical angles, supplementary angles, those are what we're going to use to start solving some compound figures. And we can look at a whole bunch of different things when it comes to that whole category of compound figures. So let's go ahead and take a look at some of those things. First, when we see number 1 and number 2, these are just your basic intersecting lines, line segments, rays, and to solve things like that, we just need to worry about vertical angles. For example, in number 1, we know that angle 4 is 65 degrees. So we can go about that one of two ways. We can either look at angle 4 and angle 1 together, which have to make up 180. And in order for angle 1 and angle 4 to become 180, angle 1 has to be 115 degrees. Or we can look at the fact that angle 4 is vertical to angle 2 because it's across the intersection there. So angle 2 is also 65 degrees, and then angle 3 is 115. So here we need vertical angles and we need supplementary angles to solve it. Those types of problems where we take the basic tools of what we know and we apply it to new and increasingly complex circumstances, that is what we do when we solve compound figures. In number 2, we know that angle 1 is a right angle. And so therefore angle 3, which is vertical to it, is also a right angle. Angle 4, which is supplementary to angle 1 and 3, is also a right angle. I didn't mean to do that there. We just have right angles all around. That's the point with number 2, right angles all around. And then number 3 and number 4, these are really getting into things that are a little bit more complex. Things where we need to know that, for example, in angle 1, which is 30 degrees, that the two red segments actually make a right angle. So go ahead and pause the video, see if we can figure out what angle 2 and angle 3 need to be based on the information that we know. Remember, the big red angle is a right angle, angle 1 is 30 degrees. Since it's a right angle, what do all of the angles need to add up to? And remember that angle 1 is equal to angle 3. Pause the video, come back when you're ready to look at the answer and move on. Just see what you can do. So, since we have 60 degrees left to make up the entire 90-degree angle, and angle 2 and angle 3 have to be the same, we can just split the 60 in half and they each have to be 30. Again, because we know that everything needs to add up to 90 degrees, we know that angle 2 and angle 3 have to make up 60 degrees total, and they're the same, so we can split it in half. I want to take a look at number 4, and I'm going to make it a little bit bigger here so we can see it. I'd ask you to pause the video and work on this too. There's a lot more things going on here, but everything that you know based on what we've talked about before, you can use to solve for angles in this figure. So angle 1 is a right angle, and we know that angle 4 is 25 degrees. So see what you can do to figure out what angle 2 and angle 3 would be. There's a few different ways we could do it. Some of the lines are color-coded to help you out. So just pause the video, see what you can do, and come back when you're ready to look at it. So there's a few different ways that we can go through this one. The most obvious way, perhaps, is to look at just the blue lines. Now, we can sort of cover the red line at the moment when we're looking at it. We can always look at only a specific part of a figure. But we notice the two blue lines are two intersecting lines, which means that we can make some vertical angles. Now, the angle vertical to angle 4 that's made only by the blue lines is angle 3. Because we have to ignore the red line there when it comes to vertical angles from the blue ones, because the red line has nothing to do with the two intersecting blue lines. What that means is one of two things. Either we remember that angle 2 and angle 3 are going to have to make a right angle because the other half of that straight line is a right angle, in which case angle 2 is going to have to be 65 degrees rather. Or we can look at it from the point of view that if these angle 3 and angle 4 are 25 degrees, this one is going to have to be 155 degrees. So this one will also have to be 155, and in order to make 155 from a right angle and another angle, we have to have a 65 degree angle. So that's the idea behind solving compound figures. It's just taking things that we know and using them to solve for parts of different problems. There are 3 more problems here. What you'll need to know to solve any of these 3 problems are exactly what we've talked about for this video. Also, the number of degrees in a triangle, a quadrilateral, and how to find the degrees of any polygon of any number of sides. So if you need to go back and watch those video lessons, go ahead back and do that. Otherwise, let's continue here. Pause the video, see what you can do to solve for angle 1 and angle 2 in this figure here. So we need to know a few things. First, we need to know that a triangle itself has 180 total degrees. So that's going to be really helpful. And we need to know about vertical and supplementary angles. So this angle here, this 42 degrees, is vertical to this angle, which is inside the triangle, the one that I'm coloring in green now. Not to angle 1, but just because if we only looked at this part of the figure that I'm bracketing in yellow, we just have 2 vertical angles. If you want to use your hand to cover up the part of the screen that's not in those yellow brackets, you'll see what I mean. What that means, though, is that angle 2, which is supplementary to 42, has to add up to 180 degrees, so this is 138 degrees. And then in the triangle, we know that the triangle, which is being outlined. So since the triangle has 180 degrees, we have 90 with the right angle, 42 with the other angle, which is 132 total, which means that our last angle there needs to be 48 degrees to make it to a complete 180. Remembering that a quadrilateral has 360 degrees, we can use the same sort of process on this one. Go ahead, pause the video, see what you can do about finding angle 1, 2, and 3, remembering that the blue figure is a rectangle, and then come back when you're ready to go through the answers. So we can go through this in a number of different ways. The first thing that we know is that because angle 1 is an angle of the rectangle, it is 90 degrees. And then we can either look at the triangles or we can look at the complete rectangle. So if we look at the triangles, we know that this missing angle here that does not have a name but completes that triangle has to make everything add up to 180 degrees, so that's 53. And then from there we can find angle 2 by looking at the right angle, because angle 2 and the 53 degree angle are complementary, which means angle 2 is 37. Or We can look at it straight from the right angle in the lower left corner with angle 3 and the 37 degrees and find out that angle 3 has to be 53 degrees there. Last one, take a look at this hexagon. Again, you'll need to remember the formula for finding the total measure of all of the angles of a hexagon, which is n minus 2, n being the number of angles, times 180. And then since it's regular, that means every angle is the same. Go ahead, pause the video, see what you can do with this one, and come back when you are ready. So plugging 6 in for n here, we end up with 4 times 180, which is 720 total degrees in the hexagon. Divide it by 6 to get that each angle, including angle 2, has to be 120 total degrees. That means for angle 1 up in the upper left-hand corner, this angle here that's outlined in green is 120 degrees. We already have 90 degrees, so angle 1 is 30 degrees. Again, when it comes to solving compound figures, it's taking a lot, or rather a few things that we know, fairly simple ideas, and just breaking down these large figures into smaller pieces so we can use what we know to find the missing parts.